Okay, let's dive right in. Our sources today are really focused on, well, maybe the biggest challenge facing AI right now.
You mean the energy consumption and the heat?
Exactly. I mean, training these huge LLMs, running assistants in real time, it generates just staggering amounts of heat
Uh,
and needs so much power. It's becoming, seriously expensive and maybe even unsustainable for the environment.
right. But what's really interesting in the material we looked at is the proposed solution. It's kind of elegant, actually.
Okay.
It's not some brand new super complex cooling system. It's industrial lab-grown synthetic diamonds.
Diamonds, seriously. Like the gemstone?
Well, yes and no. Not jewelry, definitely not. It's about using the unique physical properties of diamond for, a cooler, much more efficient computing future.
Huh. Okay, so that's our mission for this deep dive then. Unpack why diamonds, the hardest stuff on Earth, are apparently the key to, well, eco-friendly AI.
Yeah, it really boils down to physics, just comparing diamond to silicon, which is, the standard for chips today.
Right.
Silicon starts hitting its thermal limits, starts degrading around 150 degrees Celsius. Diamond, it can handle up to 700 degrees C.
Whoa, hold on, 700. Why would we need that much tolerance if silicon dies at 150? Is that just like massive overkill?
It's not just about surviving the heat, though that helps. It's more about how quickly it can move heat away. That's the real game changer.
Ah, okay.
Diamond has, get this, 5 times higher thermal conductivity than silicon. 5 times.
5 times.
Yeah. So think of heat trying to move through silicon. It's like walking through thick mud. In diamond, it's like running on smooth pavement. The heat just gets whisked away almost instantly.
Okay, I see. That speed must be incredibly important for AI, right? With those sudden massive spikes in processing and power draw.
Precisely. You get these huge heat bursts, and diamond can just pull it away immediately, preventing slowdowns or damage.
And how do they actually use it? We're not talking about embedding big diamonds in computers, are we?
No, no, not at all. The sources talk about creating these ultra-thin, basically flawless films, atomically thin layers.
Wow.
They essentially grow them onto wafers. There's a process called chemical vapor deposition, or CVD. It's like a high-tech furnace for growing diamond layers.
CVD. Got it. So the physics makes sense. They can make the material. How is it being applied? Is this actually scalable or still super expensive?
Well, the sources highlight two main ways it's being integrated right now, and they seem pretty practical.
Okay.
First is using them as diamond heat spreaders. Basically, a super thin diamond film goes right on top of the chip.
Like a little heat highway.
Yeah, exactly. An exit ramp for heat, pulls it straight off the processor very effectively. It's kind of a quick, high-impact fix.
Makes sense. And the second way, you said it was more foundational.
Yes, that's using diamond as the actual substrate, so the base material the transistors are built on.
Instead of silicon.
Right, instead of silicon. This allows the whole chip design to handle much higher power density and speed right from the start. That's where the really big long-term gains could come from.
Okay, so let's connect this back for the listener. What does this mean for sustainability, for cost?
The benefits look pretty significant. Better heat control means, well, fewer system crashes, hardware that lasts longer. Pretty straightforward stuff.
Uh-huh.
But the energy savings numbers are really striking. One source estimated that using this diamond tech could cut energy used just for cooling in data centers by up to 25%.
25%, just
Yeah.
from better heat management.
Yeah, and when you think about how many data centers there are and how much power they use, that's a massive saving, both financially and environmentally.
And you said this isn't just theoretical. Are companies actually investing?
Oh, absolutely. The sources mention big names exploring this: Microsoft, IBM, Intel. nvidia is apparently looking closely at these heat spreaders for their next-gen GPUs, specifically for those intense AI jobs.
Yeah, but GPUs generate enormous heat.
Exactly. And it's not just experiments. There are companies already shipping products. Mitsubishi Electric uses diamond semiconductor parts for really tough industrial environments. And a company called Element 6 is a major supplier of these synthetic CVD diamonds, specifically for chip cooling. The industry seems to understand that AI's growth kind of depends on solving this heat problem.
So, wrapping this up then, it sounds like synthetic diamonds are undergoing a bit of an identity shift,
Mm-hmm.
moving from just being, a luxury good to potentially becoming a really essential piece of technology for sustainable AI. It's this amazing balance of speed, toughness, and eco-friendliness.
Absolutely. Which leads to kind of a fascinating final thought, building on what we read.
Go on.
Well, if the hardest material we know, something we usually think of as purely luxury, turns out to be crucial for building sustainable, powerful technology,
Hmm.
How might that change our whole idea of what valuable materials are?
Oh,
As we maybe start prioritizing eco-innovation over just raw power or traditional status symbols?
yeah. That's definitely something interesting to think about as AI keeps evolving. You're